is machine learning techniques in smart grid. Before going to that, we have to understand what are the devices or components it's in smart grid system, and how our machine learning or artificial intelligence give the give the support to this smart grid systems. So when we talk about cyber physical systems, so when that word comes into that system means when you are carrying the IoT devices in the system. So we can say it's a system means any system. It's not only the smart grid. You can take any system, whether it's in healthcare technologies or in your home or in your city. That's what that word it's coming as smart cities, smart building, smart homes, even smart grid. So how this word's coming and all because of this cyber physical systems. So what the cyber physical system means, once you integrate the sensors, communication protocols, some computational tools and all, then your system becomes smarter. So that just we are integrating the this communication devices into it. So once if we come into that communication, then just we are having that wired and wireless communications. In a wired and wireless communications, we are having the different protocols. So with that protocols, if we are connecting our system into that internet, right? So that becomes your cyber physical system, or you can say that is the application of the IoT in smart grids. Okay, so before going to that, we'll see what is a smart grid. So once if you understand that basics of smart grid, then then it will be easy for us to understand where we can develop our machine learning or artificial intelligence techniques to apply into it. When we come into the energy transformation, before discussing about the smart grid, why the smart grid get popular nowadays? The main reason is because of the energy sources. In that energy sources, we can say distributed generation sources. We will see what is the distributed generation sources. So before it, we will discuss about the energy transformation by 2050. So when we discuss about the energy transformation by 2050, the main objective of this theme is to reduce the carbon emissions. So that is the Paris, even you can say it's a Paris Agreement of Paris Agreement. So that's what even all the countries, they have joined this forum, and they are trying to bring the environmental friendly globe. So in this case, if we discuss about the environment and all, then the most of the carbon emission is coming out of the power generation plants. So that's what they are trying to reduce the carbon emissions by 70%, in power generation units. So for that, what is the alternative? So that's what just we are moving to the alternative energy sources, such as wind and photovoltaic systems. So these wind and photovoltaic systems are called renewable energy systems. So when we are moving to the renewable energy systems, we need not to depend much on the thermal power plants, so that we can able to reduce the carbon emissions. And another thing, if we look at it, because of having this renewable energy systems, we can able to reduce the energy cost. So how we can able to reduce the energy cost means, just we can even we can realize that reduction of the energy cost by looking at the MNRE website. In India, just we are having the separate ministry for new renewable energy sources, Ministry of New Renewable Energy. So if you're visiting their website, you'll get to know that the electricity price is getting cheaper. The electricity generated from the wind and photovoltaic systems. Even 6 months back, if you have seen, the bidding cost of this renewable power is 2.7 rupees per unit. But in that 15 days back, there were a news NTPC is ready to supply the power with 2.1 rupees per unit. So that's the lowest bid in the bidding process. So that's what we can say. The energy cost is coming down day by day because of this renewables, right? And another objective is to enhance the energy security of the country. So how we can improve the energy security of the country means, even in India, 80 to 90% of the power is generated from the thermal power stations. So for these thermal power stations, the fuel are imported from the other countries. We can say some developed countries like coal and oil. So once the developed countries they stop to export their coal and oil, we will be in demand, right? We will be in the shortage. So how we can manage it? Sometimes we may have the reserves. By using that our reserves, we can able to run our thermal power plants. But for long run, that is not sufficient. So for that, I mean, if it's not sufficient, then they will demand the price for their coal and oil. So then we have to, depending on their coal and oil. So we can say the energy security of the nation is questionable. So once if we are having this renewable power generation sources, we can able to enhance our energy security. So that's what we can say. Almost 60%, 64% of the fossil fuels are imported from the other countries. So that 64% we can replace with this renewable energy sources. And when we come into the energy access, so that is very much required. If we consider in India, just 8 to 10% of the villages are not connected to the electrical grid. So what will happen? Just in these locations, there is no development happen. Even there is no technology development happen. Assume that if you're not having the electricity to the particular location, then there won't be any development happen. For example, there is no job opportunities, there is no industrialization, or even we cannot use any of that technology developed products and all. So in that case, by having this renewable energy sources, we can able to supply the locations. So that means we can able to create the standalone systems, and we can able to supply that system. So we can consider the hilly areas. In hilly areas, you cannot able to establish that network over there. So it's very difficult to establish the network. So during in that locations, this renewable energy sources plays the great role to supply the loads, right? So that we can say we can able to access the 100% energy in the country. So that and all is achievable only by the renewable energy sources. So that's what every country now going with the renewable energy sources. So apart from all these objectives, the main objective is to create the job opportunities. So this is a socio-economic perspective. So once if these technologies are growing, then you can able to create a lot of jobs in this area. So these are the main objectives to go with the renewable energy sources. So what is the estimation? So if you look at that renewable energy by 2050, almost in 2020, just we can have, you need around 35,000 terawatt hour per year. When you calculate for 2050, that means estimating for 2050, you require the 65,000 units per year. So out of this 55,000 units per year. So out of this 55,000 tera units, not units, is a terawatt hour. So out of it, 86% of the energy is generated by the renewable energy sources. So that's what renewable energy roadmap giving the idea. So this 86% of the renewable, the energy is generated from the renewable energy sources. This out of that, out of that, if you look at in the second figure, almost 6,000 gigawatt of the power is generated from the wind alone. That means only the wind energy plays the larger role. Then another 8,500 gigawatt of the power going to generate from the photovoltaic systems. So these wind and photovoltaic systems will dominate in the future. So that's what people are going to the restructuring of the electrical grid. So when we come into the restructuring of the electrical network, that is in an earlier case, just we had some conventional grid. So from the conventional grid, you are moving to the smart grid systems. So in a conventional power, when we talk about the conventional power grids, so there you are having the power generation. Then the power generated from these sources are transmitted and distributed to your loads. So these loads are located in the yellow color line, and here in the gray, just we are generating the power, transmitting and distributing to the loads. So this is the one-way communication. Earlier, if you look at it, it's not only one-way communication; it's a one-way power flow. Just we are generating the plants, and you're transmitting and distributing. So this is a one-way power flow. So here in the distribution, we are having the primary distribution and secondary distribution. The primary distribution connected to your homes and offices, and secondary distribution is connected to your home and buildings. The primary distribution connected to your industries. So industries require higher voltage, so that the primary distribution to the industries, and secondary distribution for the homes and cities. Okay, so this is the conventional one. So where this smart grid comes into the picture. So earlier they do not have this electric vehicles, this wind and photovoltaic systems. Only this conventional power generation plants and loads. Okay, so now if we look at it, because of the technology development, your loads also nowadays getting smarter, right? Your loads also now getting smarter. So how we can say the loads also getting smart means, because of industry 4.0, the factories also is getting automated. And when we come into the houses, in our houses earlier we do not have any rooftop photovoltaic systems, or we do not have any kind of smart devices that can able to communicate to other devices. So like we can say it's a machine to machine. You can take any machine, like your phone, your laptop, or your refrigerators, air conditioner in your home. That and all, it's a machine. So these machines earlier could not able to communicate each other. Once you turn on your switch, the washing machine or air conditioners can start to do the task. But now, because of this technology, every device can able to communicate each other, because just you are connecting your machines with a common network, right? So that your home also now getting smarter. Even if you consider your surveillance camera, your TV, your DTH, everything is interconnected. Now, I mean, what I'm saying is, just if you're having common setup box, in the common setup box, you're connecting your surveillance camera, your DTH services, even that setup box is connected to your Wi-Fi, right? So whenever you're required, you can able to see your surveillance camera from your phone. So that's what we can say. The houses also is getting smarter, and offices, yeah, exactly. Offices also it's getting offices or buildings also getting smarter. So what is I mean, why we have to worry about the smartness of these loads? Why? Because here when we come into this earlier grid system, there is no communication devices. But here in the loads, just we are having the communication devices. So this is a necessary for the distribution system also to integrate with the communication protocols, or you can say that they are establishing the communication between the devices to make the system perform good. So that perform good. At the same time, how we can say the performance is good means if any fault happen, immediately it can be communicated. At the same time, for identification of the fault from the distributor side also, it's very easy. So if any fault happen, they can able from the station itself, they can able to say that which building or which house we have the fault, or in a which in a distribution system in which feeder it's having the fault. So this kind of automation is required in a distribution system. So that's what just we are automating the distribution networks as well as the loads. And next part, when we come into this the wind and photovoltaic systems. So these wind and photovoltaic systems are connected in the distribution networks. Even our rooftop PVs or wind turbines, these wind turbines are connected in the primary distribution. So it's not located in the generating stations, right? So these are located in the distribution network. So that's what these renewable and photovoltaic systems are called, distributed generation sources, right? Distributed generation sources. So these are connected in the primary distribution. So here earlier you have the generation stations and supplying the power to the loads, but here these sources also is coming to the primary distribution. So what is the advantage of having this distributed generation sources in the network? Anyone can have any idea about it? Why we are integrating this wind and PV in the distribution network, and what is the advantage of it? Any idea from the participant side? Okay, here by having this renewable energy sources in distribution networks, you're reducing the losses in the system. So how you are reducing the losses in the system means, earlier, just we can see here, just you are generating the power, you are transmitting and distributing here. So transmission and distribution losses are around 20 to 25%. So, but here what you are doing, just you are integrating your sources near to your loads. So this distribution transmission losses are avoided. So you are integrating your wind PV in the primary distribution that is near to the load. Whenever you are having that more demand, then excess power is supported from the grid. So whenever you are having the excess power from that wind and PV, that can be supplied to the other, other loads in the network. So in this case, the transmission and distribution losses are reduced in the smart grid system. So that's what people are working on, different algorithms, we can say different algorithms to place this distributed generation sources in the grid. So even you can see that optimal placement of wind and photovoltaic system in the distribution networks. So that's what people are working on, different artificial intelligence and some machine learning techniques to place this distributed generation sources in the primary network. And when we coming to that other part, electric vehicles. So how these electric vehicles can be a friend of this distributed generation sources. Even that's what people, even if you ask electrical engineer, they will say for deploying these electric vehicles are good for the electrical infrastructure. Why means, here nowadays just we are increasing our renewable power generation sources in the smart grid. So here the power output from this wind and photovoltaics are not constant. Why? Because that wind velocity and irradiance is depending upon the nature. So it will keep on change. It will keep on change. So what will happen? Just we are injecting the intermittent power to the network. So because of the intermittency of these sources, you'll have the stability issues, right? You will have the stability issues. Why the stability issues comes into the picture means, you cannot able to match your source and demand. If you cannot able to match your source and demand, then you cannot able to maintain the stability in the network. So for that time, you need some energy storage devices. Like example, we can say in our home, when the power goes, just we are using the UPS. The same way, you need some energy. I mean, in a UPS, we are having this energy storage. So for when we consider this large power system also, it requires some energy storage. So here, because of having the large energy storage, they can able to mitigate the intermittency of this wind and photovoltaic systems. So here, yeah, we have to install the large scale energy storage system. So now, instead of installing the large energy storage system in the primary distribution, the primary distribution network, you are having the electric vehicles. So what to do is, if you consider that, if you are taking any building, you can consider the apartment. In an apartment, you may have 100 houses. In 100 houses, at least you can have one or two, one, you can say so one electric vehicle. So in that electric vehicle, you are having the battery. So what you can do is, by using this machine learning techniques, you can able to aggregate all these electric vehicles in the network. So once you aggregate all the electric vehicles in the network, you can able to estimate the energy storage available from these electric vehicles, because just we are using the battery in that electric vehicle. Once they connect their electric vehicle to the network, you can able to aggregate all these electric vehicles in the buildings by using the algorithms. So once you can able to aggregate all these energy storage in that electric vehicles, that will give the great support to the distributed generation sources. How means it's very simple. Earlier also you have used the energy storage. So by aggregating this all the electric vehicles in the buildings, you can able to aggregate some energy storage. So that energy storage give the support to your large scale energy storage. That means you need not to go that capacity. Instead of that capacity, you can able to reduce the capacity of the energy storage, so that you can able to save the cost in the smart grid system, right? So for this purpose, just you can use your machine learning techniques to aggregate it. Even you can take any machine learning techniques to aggregate all these electric vehicles in the network, and you can give the support to the smart grid system. You can support means you are giving the ancillary services to the smart grid systems, right? So that and all is possible with the that is also possible in the smart grid system. So that's what people are heavily working on, the aggregation of these electric vehicles in the smart grid. So even the persons who are familiar with the machine learning and artificial intelligence, for them it's a good application. So they can work on to aggregate all these electric vehicles, and they will see that how the aggregated energy storage plays the role in the smart grid. Accordingly, you can able to reduce the size of the energy storage in the system, right? So one way, one of the application of the artificial intelligence and machine learning. Okay, another thing, when we come into the houses, so houses, just we can say for example, I'm considering the variable tariff system. So in a variable tariff system, during the peak hours, your electricity price is higher. During off-peak period, your electricity price is lower. Normally, this is the case. Like our Uber, Ola cab services are there, right? The same way. Whenever the demand is high, they will charge you around 2 or 3 times more than the base fare. So if the demand is less, then they will come below base fare also. So the same way in electricity also, in a future, there is a possibility to come with the variable tariff structure. So when you're coming with a variable tariff structure, so you have to reduce the electricity bill in your home or any offices or in factories. Even that's what we can say, this energy conservation and management is getting popular nowadays. So instead, why they are asking you to save that electricity means, so for generating the electricity, just we are spending almost 100 rupees. So because of the subsidy and all, you are getting the 8 rupees or 6 rupees per unit. So that's what they are promoting, the energy conservation. If you are saving at least 1 unit here, just we are benefiting only with the 8 rupees. But when I look at from that generation perspective, I can able to save 100 rupees. So that's what they are promoting, the energy conservative measures. So how this energy conservation and energy saving in the smart home is possible? Once you are getting the variable tariff, so all your devices, gadgets, appliances, for example, your refrigerators, air conditioners, dishwashers, washing machine, heater, your TV, everything is connected with your home area network. So you can able to connect all these devices in the network. Then you can have your own autonomous system to control all these devices based on the tariff price, right? So based on the tariff price, you can able to control all the loads. You can get to know when you need to switch on, when you need to switch off the devices in your home. So normally in electrical engineering, we will call that technique as a demand response management technique. Or simply they will say is a DRM, demand response management. So demand response management algorithm and all is possible in the homes, not only homes, even the big offices, factories. So because of this demand response management algorithm, you can able to save the energy. At the same time, you can able to shift the loads from peak hours to off-peak periods. So off-peak periods, your electricity price is low. So just you are connecting your gadget into it, so that you're operating the gadget optimally in the home, so that you can able to reduce your electricity cost of electricity bill to your home. So this kind of DRM algorithms and all possible by coming with the smart grid technology, as well as getting with the variable tariff system. So where our machine learning people can work. So here for optimum operation and taking the decision, and just we can able to develop some machine learning algorithms. So that's what just we are, the persons who are skilled with the machine learning, they are having a huge opportunity to work on any components in this smart grid systems. Any component, you can take home, you can take cities, offices, electric vehicles, renewable power generation sources. You can take any component in this smart grid architecture. Just we are having the huge opportunity to develop your algorithms. You can say it's a machine learning techniques to optimize the operation of the device or operation of the system. Even if you take the entire system, assume that in India, just we are having the uh, few lakh kilometers of the transmission and distribution lines. So just when we come into that, we are having a lot of devices in it. So you'll get a lot of data out of the devices and subsystems. And how we are going to take the decision with the data. Obviously, just we need to develop the algorithms for it. So in that way, your your machine learning can be useful in this smart grid architecture. And another thing, when we come into the smart building, so cities and offices, you are having the high-rise buildings. In the high-rise building, smart lighting control is there. Just we are having the surveillance camera systems. So you can able to just integrate. You can able to communicate each and every devices, so that you will get the data also from the devices. That how you are going to use it for we can say for enhancing the performance of the building. So in this case, for example, we can take the smart lighting system. Earlier, normally they will use the sensors to measure the intensity of the light, and they turn on and turn off. Now, in every building and every floor, now we are having the surveillance camera, right? So by using the surveillance camera, you can able to control the lighting of the building. Yeah, it is possible. Why? Because just we can take the image of that image or video of the surveillance camera. Just we can process it by using the image processing techniques, and you can able to get to know the intensity of the light in the images or videos. Based on that, you can able to control the light of the building, right? So just we are having the futures into the system, right? So in that way, just even one of my scholars is working on that smart building. In a smart building, how we can able to control the lighting by using the surveillance cameras. So even we are having the sensors also. In addition to that, we are taking the surveillance cameras output like an image or video. So just we can apply some image processing technique. Then you can come up with that light intensity of that location. Then you can control your light. So when you are talking about the image processing, then the machine learning come into the process, right? So any discussion or any queries on this topic? Hello. Yeah. Any questions? Yes, sir. Yes. Okay. Any question? Yeah, I can go forward. Yeah, sure. So this is a smart grid structure. Now we'll see what are the devices you are having in a system to make smarter. So that's what we can say the role of IoT in smart grid. So IoT also plays the major role in the smart grid systems. So here when we come into that IoT devices or in a communication devices, earlier just we had the passive communication. So in the passive communication, the device can communicate when you raise the query. So the example is RFID system or QR code system. So these are the example for the passive communication. So then active communication. So whenever you need it, you can able to get the information from the sensors. So that is the active communication. So that means your communication link is active. Then oftenly that information is passing to the passing from one device to another device. Then they come up with that they have added the feature of awareness. So when we can able to add the awareness to the system means once you are having any computational tool. So once you are having any computational tool, for example, if in your system, for example in a smart grid or in your home, once you are having some processors in it, so the processors can perform the some mathematical operations or logic operations. By using that logic and arithmetic operations, you can able to take the decisions, right? So that decisions means depending upon the conversation between the two machines or machine to human or human to machine. So any way. So in that simple, by having that computational tool in a system, you can able to make your system interactive, but without having any, we can say, without taking any decision on it. It's not about the decision. Just we can query, and that will give answer, right? Only this way you can able to make the system aware. But now, when we talk about the autonomous system, in an autonomous system, you can able to take the decisions. You can able to take the decisions, and based on the decisions, you can able to control the devices in the system. So that's for that. Just we have to incorporate the machine learning techniques to take the decisions. So these decisions will be taken based on rules. So that is the algorithm developer can take care of it. What are the rules you have to follow it, and you have to define it, and you have to author with that rules. So the best example of that autonomous systems are autonomous cars and smart systems. So even the autonomous car, just we are having almost more than 1,000 number of sensors. From the sensors, just we are getting the feedback, And the same way, your your processor also need to take the decisions that much quick. So that's very important. Even within second or within few seconds, you have to take the decision, even more than the human power. So if your car can able to take the decisions, then this autonomous cars are going to be very successful. So here the very important thing is, when we talk about the autonomous system, just you have to integrate large number of sensors. From the large number of sensors, you're getting the large number of data. Then you have to process this data, and you have to get a record demand from this record demand, or you can say that you're taking the decision making from the data, and that decisions can be passed to your another device to perform the task, right? So, for example, steering control, that's very much required in a autonomous car systems. So, this and also evaluation in the IoT things. When we come into that application of IoTs, so application of IoT, when we talk about, there are number of areas. So in this number of areas, if you look at it, that on the top, you are having the automation of the houses. So automation of the houses, they are saying it's 100%. You are having the application of IoT in it. So how we can justify? So any idea, any discussion on it? How we can say the IoT plays a major role in the autonomous, making our house as automated? Any discussion on it? Just think of it. I'll come within second. Any idea? Any idea? How just we are using IoTs for making our home smarter? Okay, the best example is just in your home, you're having the Wi-Fi device. So in a Wi-Fi device, what are the devices you are connecting with it? Your phone, your laptop. Other than that, how about your set-top box? Is it possible to connect your set-top box?
No.
No. Yes. Now just we are having even Airtel. They are having the Extreme box, right? So in this Extreme box, they are come up with OTT platforms like Netflix, Amazon Prime, and all. So for using these OTT platforms, you have to connect with your Wi-Fi. So then even they have launched the Airtel Extreme box. You can check it out. Even earlier, they have this Google Chrome, or I don't know exact name of it. Yeah, with that we can able to have the OTT platforms on the TV, right? So just we are connecting your set-top box with the Wi-Fi, and if you are having the surveillance camera in your home, that box also, that processing box also, you can able to connect with your Wi-Fi, and wherever you are, we can able to access that camera, and you can able to see that video streaming, right? So even the example is, even nowadays schools also, they are giving that option, right? So for kindergarten schools, even you can able to see your children activity by connecting with their network, right? So that's what we can, even nowadays we are coming up with smart switches. Instead of having our normal switches, we can go with the smart switches. Smart switches means in that switch, just we are having that wireless connect. You can connect that switch with wireless connection, That means just we can have the Wi-Fi enabled switches. So that switches, instead of our normal switch, if you are having that switch is also connected to your Wi-Fi network. And other thing, even now we are getting with this smart refrigerators, smart air conditioners. So the smart air conditioners, smart refrigerators also, you can able to connect with the Wi-Fi network. Even if you are having the printers can able to connect with your Wi-Fi network. So that's what we are doing is just we are connecting all the devices to the network, the common network, whether it's a wired network or wireless network. That is, I mean, it's depending on the device, right? So here, if you're connecting all these devices into your network, then what will happen? You can able to communicate to each and every device. Am I right? Once you are having the mobile phone, if you are having the GUI in it, that mobile also is connected to your same Wi-Fi. So we can have the control over the other devices also, right? Other devices which are connected to the same network. So it is possible to make the centralized control of your home, right? So this is having the advantage in the perspective of house owner. So if any hacker comes into that, then your entire home is under the control of the hacker, right? So that's what there are a lot of cybersecurity engineers. They are working on the IoT field. So that also it's booming up. So in this way, just we can say there is a huge scope for IoT application in smartphones, right? So even next one we talk about wearables. So in wearables, we are getting with the smartwatches. That smartwatch also you can able to connect with your home Wi-Fi, right? Okay. So that smartwatches, not only you are having the watch for looking the time, at the same time that can measure your heartbeat, that can give you how much steps you have walked on that day. So it can act as some healthcare device, right? So that can in the healthcare, I mean, by measuring that heartbeat and I mean your steps and all, it can give a lot of tips for you, right? To make your health fit. So here also again the algorithms come into the picture, right? So these variables and smart city. So when we talk about the smart city, just we are having the various energy systems in that smart city. At the same time, you have to maintain the transportation, your services, and everything. So how? I mean, again, just we have to use algorithms and strong computational tools to make the decisions and to regulate the services to the consumer. So that's what there is a huge scope for digitization in these fields. Then the fourth one is smart grid. Yeah, smart grid. Earlier, just they have one-way communication. That too not a one-way communication. In the transmission system, we are having the communication between the sending and receiving end. Other than that, there is no communication in the distribution networks or in the consumer side. So if any fault happen, you have to call to your EB office and get the personnel to rectify it, right? So that also it's we can say it's a passive communication, right? So that's what there is a huge scope in the smart grid to deploy these communication devices to make the devices interact each other. So if the devices interact each other, that will be good to take the decisions at the same time to enhance the performance of the system. And the industrial internet also is similar to that IoT. Here they will call industrial internet of things. They are having their own protocols for communication. So that's what they are saying is the industrial internet of things. At the same time, when we talk about the homes, if any fault or any small fault happens, okay, we can able to tolerate it. But in industries, just your control should be very precise. Control or monitoring should be very precise to avoid any losses in the industries. So in that case, your communication should be very strong. At the same time, any intruder should not hack your system. That's very important. So that and all, it's coming in under industrial 4.0, industry 4.0. At the same time, because of this IoT, we are having a lot of technology change in the every field, right? So that's what I want to convey here. One of the field is smart grid. Smart grid also having the application of this IoT devices. So why we are going for IoT devices means nowadays we are getting the cheap sensors. So the sensor cost also reduced drastically. Even if you look at the voltage and current measurement, in earlier voltage and current measurement, we use the potential transformers and current transformers. So that potential transformers and current transformers also is bulky. At the same time, the costlier. At least we have to spend 5,000 rupees in the medium voltage level. But now, just we are having the Hall effect sensors. So that Hall effect sensors are like 1,000 rupees. So just simply you can able to measure the voltage and current with a cheaper price, right? At the same time, for measuring all these mechanical parameters and electrical parameters, sensors are available. That too very cheap, even for I mean few hundred rupees, even not few hundred rupees, even below 100 rupees, you can able to buy the very precise sensors. So that's what for deploying these sensors in your systems and are very cheaper. And bandwidth. Yeah, when we come into the bandwidth, even the Geo, because of the Geo, we are getting a very cheap data, right? So the same way, the bandwidth also, we are having a very good bandwidth. So with that bandwidth, you can able to communicate with each and every devices, and you can communicate the data to the processors and all, right? That and all is possible. And processing, yeah. When we come into the processing, even for every 6 months or every year, just we are coming up with the new processors, right? So that processor's powers also it's increasing, right? The speed of the processor also increasing. So that just we are having the very good computational tool to implement your all the algorithms in your system. All the algorithm means even in some of the applications, the processors are limited. So you cannot able to implement your machine learning techniques in that. So now in a real time, just you can by having this cheap processors, you can able to integrate all your algorithms into the chip, and you can able to operate the system. And another thing is smartphones. So yeah, it's like a remote controller of anything. You can use your smartphone as a remote controller of anything, so that you can able to you can able to control all the devices in your network by using the smartphones. For example, because of the smartphone, earlier just when you are going out, just you have to take your wallet, right? So wallet means is here purse. In that purse, you may have the currencies, credit card, maybe your ID card, driving license, credit cards, right? But you can think of it now. Now, if you have the mobile phone with you, you need not to take anything for even during travel also. So you can in a mobile phone, you are having the mobile wallet, right? So like Paytm, GPay, and so you can pay wherever you want. Even the petty shop also you can able to pay. And another thing, if you are traveling with your vehicle, earlier we have to carry the hard copy of your RC book and licenses. But now you need not to carry any hard copy of your license or hard copy of your driving license and RC book. So even just we are having the Parivagan app. In that Parivagan app, just you can link your RC and the driving license, then simply you can show it to them. That's enough. You need not to carry the hard copy of it. At the same time, credit cards, debit cards, it's not required. That's why you are having the mobile wallet. You can pay it wherever you want. So that's what. In the same way, for example, if you are having your smart air conditioner in your home, that air conditioner is connected to your home Wi-Fi. So that Wi-Fi you can able to access through your smartphone wherever you are. So just if you want to control the temperature of my air conditioner, I can able to control from my phone, right? So I mean, if it's wireless, then if you're using Wi-Fi from in your home itself, you can able to control it. Even I told no Airtel Extreme Box. In that Airtel Extreme Box, it's not IR sensors in it for the remote. It's a Bluetooth connected. So if you're not having your remote, you can use your smartphone also as a remote. So if you are in another room, also you can able to control the TV. So that's what the technology improvement. So just we can use your smartphone for controlling any devices in your home. So because of that, just we are looking for the IoT in the any system. Because of the technology, just we are having a wired and wireless technologies. So because of that, just we can able to communicate each and every devices in the system. And even if you are increasing the number of sensors, if you are increasing the number of sensors and some computational tools with that devices, then you are creating a large number of data out of it. So how you are going to deal that data? So that's very much important. So for that purpose also, people are coming up with data mining and all, right? So these are the areas you can work on it. So when we come into that smart grid, or when we call it a cyber physical system. So when we call our system as
all departments, publications, మీకు వాట్సాప్ లో రికమెండ్ చేస్తాను అట్లా కావాలి అవునండి అట్లా కావాలి కాదు కావాల్సింది
yes wait yes okay it's not to me. Okay, so when we come into that cyber physical systems, or you can say it's a smart grid, just we can define that smart grid or cyber physical system in that way. So cyber physical system is a system, or smart grid is the system. So in that system, if we integrate the sensing, that means just we are integrating the more sensing, and you are making the communication among all the devices. So integration of the sensing, communication among all the devices, so that that can interact each other. Then third, just integrating the computational system. So once you are having the computation, then you can able to take, I mean, the system or device can able to take the decision by doing some calculation with the data. So for that, you have to integrate the computation, and finally, just you have to control the devices, right? Just you have to control the devices. So once if you are having these four technologies into your system, that system will become a smart system, whether it's a grid or whether it's a home or industry. You can say it's a smart grid, smart home, or any smart, I mean, that's a smart system. So that integrating the sensing, communication, computation, and control, these four are very much required to make your system smarter. So once you are integrating all these three, sensing, communication, computation, and control, why we are integrating these technologies? So we are integrating these technologies to achieve the monitoring of the system. We can able to monitor the system. Even each and every device in the system, you can able to monitor it, and you can able to track it. If any fault happen, you can able to identify the fault location, and you can rectify it, and you can reconnect your devices to the system. So that and all is possible. So why we are doing it means for monitoring, tracking the devices, and management. So you can able to manage all the devices in your system. So that's what in a smart grid, if you talk about smart grid, energy management system. So in energy management system means just we are matching your supply and demand there. Supply and demand, for matching the supply and demand, we are having the energy storage systems. So how these energy storage systems, sources and loads are managing the power. So that energy management system also possible in the smart grid system. So that management and location identification. So for this purpose, just we are making our system smarter, right? So that's what just we are earlier. Easy people, they work in one direction, and the electrical engineer, they work in their own domain, like generation, transmission, distribution. Here, when we come into the communication, they are having the wired communication and wireless communications, satellite communications and all. But now, just even the we can say communication people also looking for the application. And as an electrical engineer, I'm also looking to enhance or adding the features into my system. So that's what these two engineers now coming to close, right? Okay, so smart grid. When we talk about the smart grid, we can say we can able to integrate the advanced sensing, communication, computation, and control methodologies in the transmission as well as distribution levels. We are adding these technologies in the transmission and distribution levels. So by adding these technologies, we can able to monitor, analyze, and control the grid components. So for that purpose, just we are making our system as smarter. So here, by adding the communication with each and every device of the system, we can have the two-way communications. So two-way communication, at the same time in distribution network, you need two-way power flow. Two-way power flow and two-way communication. So these two are possible in the smart grid systems. So in that, once you are having the two-way communications, just we are having the lacks of components in the smart grid systems, so that we can able to control, communicate each other. So when I say the my grid is smarter, so that can able to senses the parameters in the entire system, and it can take the decision themselves. Why? Because just we are having the machine learning techniques with very strong processors, so that take the decision themselves. And by adding this energy management system, energy management algorithm and all, you can able to make your grid as clean and green. For example, how I am saying it's a clean and green means in your region, you can take a region. In a region, you are having the rooftop PV in every houses. So that time just we are having the very good irradiance, so that we can able to generate a lot of power from this rooftop PV. That power itself enough to meet the demand at your region. So that time you are not taking any power from the utility. You are not taking any power from the utility. Just you are utilizing that same PV power for your entire region, so that the net consumption of the energy for the month you can able to reduce drastically. So for example, without PV system, I'm in my region, I need some 50,000 units. So by having this rooftop PVs, what will happen? Just your demand is reduced from the grid. For example, for that particular month, I have taken only 10,000 units. So 40,000 units I'm generating myself, and I'm supplying my loads. But here, for managing this every rooftop PVs in the region, again, just we need to go with the smart grid system only. So that you can say my entire region is supplied by the photovoltaic power. So I can say that I can able to make my system as clean and greener. This is only for region. The same thing is applicable to the entire grid. So that you can say, you can, by having the smart grid, you can able to make your system clean and green. So then you can say it's grid is autonomous. So yeah, it's taking the decision themselves, and it's operating efficiently without any disturbances or without any fault happening in the distribution systems. So you can say the system is autonomous, so it's operate efficiently, right? So these are the features of smart grid systems. You can once the fault happen, you can heal yourself. That means heal yourself means system itself is healing themselves. And here just adding some cyber security measures, you can able to avoid the intruders to intrude in your network. Like just we can avoid the cyber attacks or any physical attacks to your network. So even the persons, I mean the cyber security persons, they are working on different techniques to avoid the intruders in your network. Here, active participation by the consumers. Yeah, we can see that when as a consumer, I'm also participating in the energy conservation measures, right? So that we can say just we are having the active participation into the network. And here we can able to accommodate all the PV generation. That means renewable power generations and storage options. Even the first slides I have discussed that by aggregating that EVs, you can able to reduce the energy storage in your network, right? So that option also we can able to explore by having the smart grid system. But with the current infrastructure, we cannot able to implement this algorithms and all. So for that we need smart grid, at least partially automated system. We require to go with these techniques. Now also they are doing a DRM, demand response management, in a electrical network. How they are doing means they are doing manually. So whenever they are having the higher demand, they will simply turn off the loads. So that's what in, even 3 to 4 years back in Chennai and in most part of the Tamil Nadu, we had power holidays, right? I hope you remember. So that is the demand response management. In India, we are having it, but it will improve once if we make our existing grid as smart grid. So these options and all is possible, right? So enables the new electricity market. So how we can say enables new electricity market means, for example, you are purchasing your electric vehicle. Now we are connecting. I mean, how much of the time we are using our vehicle? Do you have any idea about it? We are having the car. We are having the four-wheelers. So do you know how much percentage of the time we are using our electric vehicle? Not only electric vehicle, any vehicle. Anyone can give any assumption? You can take your car. So how much of time you are using it? If you consider for a year, how many hours roughly we are using? Oh, you can tell me in the percentage, so that will be easy for us to understand. We need not to calculate 365 into 24 into something and all. We need not to do. Just you can tell me the percentage. Shall we say it's only 10 to 15% of the time? Yeah, only just we are sitting 10% of your time you are sitting in your car, right? Other than that time, just your car is parked in your home or parked in your office spaces. Am I right? Only 10% of the time you are using your car in a year. You are using for travel purpose. Other than that time, just you are parking your parking space or in your home or in an office. So just think of it. If you are making your car as an electric vehicle, that electric vehicle you are connecting to your network. Whether you are in I mean, if you're coming to the office, in the office space also, just you are having the charger. So just we are in the charging points. In the charging points, just we are connected to it. In a home also, you can connect it to it. What will happen? Just you are connecting to the network. So once because of this smart grid, even that your system itself can able to take the decision whether your battery get charged or discharged. For example, if you are having the variable tariff system, so in a variable tariff system, during a peak hours, the electricity cost is 10 rupees. Off-peak period, your electricity cost is 4 rupees, right? So during off-peak period, your even in your electric vehicle also, just we are having the computational tool. Computational tool means just we are having the processor. So once you are having this algorithm and you are having the communicating with all the devices in your distribution network, your electric car can be connected into your charger and your battery gets charged during off-peak period. So now your battery has charged 80% of the capacity. You can say the state of charge of the battery is 80% now. So now during a peak hours, it can support to the network. So your battery gets discharged. So that time during a peak hours, you are supplying power to the network. So that time you will get the incentives, like whatever the price. So during a peak hours, 10 rupees. So 4 rupees you are charging your batteries and 10 rupees you are discharging the batteries. So this is the profit for the consumers, right? So this is in that way, people are working in the smart grid systems. Not only just we are a small players, we may get some, 100 rupees or 200 rupees profit out of it. But when you consider that large players, they have come up with very good storage units. So that storage units during the low peak hours in the network, they will charge their batteries. They can have 10,000 kiloampere hour and all, right? So they'll charge it. So whenever the peak hours, they will sell the power to the network. So they will get benefit out of it. They need not to require any power generation units. If they are having the battery, they can do the business, right? So because only when you are having the variable tariff in your system. So that kind of electricity market and all possible by having the smart grid system. So here again, I'm saying here everything depending on the algorithm. So just we have to develop the algorithm and techniques to implement these things. So that's what the machine learning is coming to the picture. So here asset utilization. So how you are optimizing the asset utilization means. So once this battery and renewable energy come into the picture, then you need not to go with the new installation of the thermal power plants. So that just we are saving the capital cost to the country. So we can say just we are optimizing the asset utilization. And because of having the different components in your system, you can able to provide the quality power to the consumers. That is very much required, right? So we can give the reliable as well as continuous power to the consumers so that we can able to enhance the efficiency of the system. So that's what finally just we are having the enhancing the operating efficiency of the system. So these are the features of the smart grid systems. So when we come into that information flow and power flow in that smart grid systems, as earlier I told you, in a power system, we are having the generation, transmission, distribution, and consumer. So in the distribution, you are having the primary distribution, secondary distribution. Primary distribution is connected to the industries, and the secondary distribution in the homes. Here, if you look at it, in a home, almost earlier we had only the loads, but now we are having the electric, because of the electric vehicles, even you are having the UPS in your system, there you are using the battery. So here we are having the energy storage system. Even if you take the refrigerators and air conditioners, in our electrical engineering, normally we will consider this refrigerators and air conditioners as loads, electrical loads. But in my perspective, I'm looking these refrigerators, air conditioners are storage units. So how I can say storage units means, in a refrigerator, you can increase the temperature or reduce the temperature. Instead of 20 degree, 8 degree, you can reduce to 7 degree or 6 degree centigrade. So what will happen? Just it consumes the power and stores the energy inside of the refrigerator as a in the form of cooling. So these are called thermal energy storage devices. So for your demand response management algorithms and all, we can able to use this thermal loads, thermal storage loads. Even air conditioner also is the same. Instead of having the uh, 20 degrees centigrade, you can make it 18 degrees centigrade. So just we are storing the energy in the form of cooling. So this is a thermal loads. So I always look at as a thermal loads. Even one of my scholars is working to aggregate this thermal loads in the high-rise building so that you can able to reduce the battery size, battery size in the microgrids, right? So in a microgrid, if you are just you are using the renewable energy systems and loads, so there you will use always energy storage over there. So by aggregating this thermal energy storage systems, you can able to reduce the size of the battery so that you can able to reduce the energy consumption and reduce the
Sir, Vijay Kumar sir.
So your voice is participants, please kindly stay online. Maybe there would be some technical difficulty with the resource. Hopefully, the resource would get back in 5 minutes.
Sorry for the delay, and there is a network issue from the speaker side, and sorry for it. We will be taking care of it soon, and feedback link will be given at 10:30 or 10:35 sharp.
Okay, I think my connection was lost, so I didn't know about it. So just I spoke myself. Okay, now
Yes, sir.
I think
Yes, sir.
are
You
you
are
able to
audible,
hear
sir.
me? Okay, just now it's
Sir, 3 to
disconnected
4
or
minutes
earlier?
before, sir.
Oh, okay. I think 3-4 minutes just I talk myself. Okay, because of your call, just I have seen that it disconnected from the network. Yeah, sure. Okay, so here, what I want to convey, I mean, where I stop the presentation to the audience. So this one, have you seen this buildings and smart homes IoT solutions? So what are the devices we are having?
So, previous slide, please, sir.
Yeah, this one.
So, one more, please.
This one.
No, sir. No, sir. Ah, yes, sir. This one, sir.
Oh, after this, I talked about 4 slides. Okay, here I can repeat. So when we come into this smart grid system, just we are having the home area network, neighborhood area network, and wide area network. So wide area network is for monitoring and control of generation and transmission systems. Neighborhood area network for controlling the distribution systems and aggregating all the components in the we can say is a home area network. So this is a IoT gateway integration. So in this, we are having the prosumers and smart meters are connected. So just we can collect the data and that can be sent it to the data concentrators, and from data concentrators to cloud, or you can say the server. So server, just the regulators and retailers can able to access that data. So from that data, they can give the policies as well as tariffs for the consumers. So this one also, just I already told you what is the application of HAN, home area network, NAN, and wide area network. So when we come into that, I skipped this one. When we come into that home automation, you are having the variable devices that until I have discussed in the first, I mean, at the beginning of the class. So here, just we are having smart switches, smart devices. So here, all the devices are able to communicate each other. That means we are having a wireless communication protocols in these devices. so that we can able to interact with these devices. So by able to interact with these devices, we can able to save the energy in the building. So that's what our main objective. So why we are going with IoT solution that home means we need to conserve the energy in the buildings. So by having these smart devices, we can able to conserve the energy in the building. At the same time, just we are enhancing the security of the house. So for that purpose, just we are moving into the automation of the homes. So I stop at this point. Just if you're having any questions, please let me know. So I'll be happy to answer. I think my time up to 10:30, right?
Yes, sir. Thanks for your presentation, sir. Any queries you can ask in the chat box. Any queries or questions related to the presentation, and you can ask it in the chat box.
Yeah, if you're having any questions or doubts, any discussion on the topic, welcome.
So thanks a lot for your presentation, sir. So we had a good presentation regarding IoT, sir. We are happening an eye-opening session of IoT, and thanks for it, sir. Can we have a group photo, sir?
Yeah, sure.
I request everyone to turn on their cameras, please. I request everyone to turn on the cameras, please. So thanks a lot, sir. Thanks a lot for your valuable presentation, and it's a good session. It's an eye-opening session of IoT, and thanks for it. And thanks for accepting our invitation, sir. And thanks a lot for all the participants for joining. And feedback link will be posted in 2 minutes. Thanks a lot, sir. Thanks a lot.
Okay. Thanks a lot, and thank you all the participants. Thank you.
Thank you, sir.